write the number in scientific notation. Now, what we're given here, 0.000433. This is a number given to us in standard decimal notation. What we are being asked to do is convert this from standard decimal notation, the way it's given to us, and convert it to scientific notation. And this is created for scientists, people who use big and very small numbers that have excessive zeros in them, and create it to create a number format that shrinks down the footprint of the number, how much space it takes up. So scientific notation has the general form of a times 10 to the r. And what we do is, this a number is a number. It's easier to show on a number line. A is a number that you find between 1 and 10. It's some number in this range of numbers on a number line, some number between 1 and 10. It can be 1, so I'm kind of plotting a big circle. It can be 1, but it can't go all the way up to 10. It can go up to like 9.999. It's just to the left of 10. So this is the range of numbers from 1 to some number just anywhere less than 10. That's what the number a that we're trying to create out of this number that's given to us. So what we do is we move this decimal point in such a direction that we create this number a out of this number. Now, if I deliberately moved the decimal point to the right enough times to make a number between 1 and 10, I'm able to see that when we move the decimal point to the right, we created this number a. And here's why: because we have 4.33. 4.33 is a number, like here's 5. 4.33 is somewhere around here in this range of numbers. If we go too far with the decimal point, we would have created one place too far, would have been 43. That would have been way over here on the number line. If we went too short, not move the decimal point far enough, it'd be 0.4, which is between 0 and 1. But when you move it just to the right place, you create a number between 1 and 10, 4.33. So our a number, if we revisit the format of scientific notation number, a is 4.33 for this number. Now we just need to find out what number we need to place for r. These are the two parts. We need to find out what a is and what r is for converting to scientific notation. Now I'm going to switch colors here to red so we can see the next part of the process. The r number is how many times we would have to move this decimal point in the a number. We start at the a number. How many times would we have to move it to get the original standard notation number back? And we count the number of humps that we generated to make the a number. So let's count back to where we came from. 1, 2, 3, 4. The number of times we have to move this decimal back to create the original number is 4 times. Now, by starting on the decimal location in the a number, here's a gimmick to realize, to figure out how, should this r number be a positive or a negative? That's the last question you need to answer. And the way I use this little gimmick is, since we have to, starting on the a number, we have to move back to the left. Negative numbers are to the left of 0. If this was like a little number line and 0 was here, positive numbers are to the right of 0. But we have to move our decimal point back to the left to regenerate our original decimal number, 1, 2, 3, 4 to the left. So that's the last decision we make, is 10 has to be raised to the negative 4 power. So the final answer would be 4.33 times 10 to the negative 4th power. and we go up here to compare our answer choices. They all look very close, especially C and D, but D here has got the appropriate negative exponent. Okay, make sure to catch all the details on that.